All right, for 8.2, we have trigonometric ratios. The objective is to find the sine, cosine, and tangent of an acute angle, and to use trigonometric ratios to find side lengths and right triangles and to solve real-world problems. All right, so your first buzzword is trigonometric ratio, or trig ratio. So let's read through this. By the AA similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with the same acute angle measure. So triangle ABC down here is similar to DEF, is similar to XYZ. These are trigonometric ratios, and these proportions are the same. That's what should be up in here. BC over AC is equal to EF over DF, which is equal to YZ over ZX. Basically what this is saying is that the short sides over the hypotenuse, they have the same ratio. So basically, they just have the same ratio. But because they have the angle, they're all the same. All right, please write this down along with the word SOHCAHTOA. SOHCAHTOA is going to be kind of the acronym that we use to remember the order of sine, cosine, and tangent. What I'm going to use these for is to find the missing sides or angles. I can use these functions, sine, cosine, and tangent, to find angles and measurements and side lengths and all that stuff. So for sine, just get this down. It may not make sense right now, but we'll do some examples and it will. When I see sine, I need to think opposite over hypotenuse. That's what sine SOH in SOHCAHTOA stands for. Sine is opposite over hypotenuse. So in this diagram, it's A over C. Based on A, if I look at A, the opposite A is the blue. Adjacent is the green. The red is going to be the hypotenuse, opposite over hypotenuse. So when I look at angle A, depending on where you're looking, you're always going to look at the acute angles. You very rarely ever do from the right angle. When we look at A, the opposite from the blue A is the little blue A. Adjacent is the green line B, and the hypotenuse is C. The hypotenuse is going to be this line every time. So when I look over at sine of B, I do opposite, so I do opposite over hypotenuse. So I do B over C. Cosine stands for adjacent over hypotenuse, so cosine AH. Again, SOHCAHTOA is what's going to help you remember the order of which one's opposite hypotenuse, adjacent hypotenuse, and stuff like that. So if I'm at A, the adjacent side to A is B. It goes over the hypotenuse. Cosine, the adjacent for B, is A, and the hypotenuse is C. And then tangent. Tangent is opposite over adjacent. That's the TOA in SOHCAHTOA. Opposite over adjacent. Tangent, opposite, adjacent. So the tangent from A, the opposite to A is the blue, and the adjacent to A is the green. Tangent of B is opposite over adjacent, so green over blue. All right, in trigonometry, the letter of the vertex of the angle is often used to represent the measure of that angle. For example, the sine of angle A is just written as sine A. You don't have to worry about the sine and the angle and all that stuff. You can just write sin A. All right, write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. So I want sine of J. So what I have to do first is write down SOHCAHTOA, and then I go to J. Since I'm doing sine of J, I'm going to be doing sine is opposite over hypotenuse. So what I first want to do is look here at J. Here's J. I want to name the opposite, adjacent, and hypotenuse based on J. So if I look at J, I've got the opposite is over here. The adjacent is right here. And the hypotenuse is right here. So whenever I start these problems, I'm always going to base it off of what letter they tell me to. Since I'm told to choose J, I go to J, and I write down my opposite, adjacent, hypotenuse. Now it's just as simple as putting in what the opposite is. The opposite was 60, and the hypotenuse was 61, which is about 0.98. So for these problems, that's all you have to do. All right, now we're going to do cosine. Cosine of j, again, write down your SOHCAHTOA so you remember the order. Still at j, so this is still opposite, adjacent, hypotenuse. So cosine of j equals adjacent over hypotenuse. That's what the SOHCAHTOA tells us. Cosine is adjacent over hypotenuse. So I just put in what my adjacent is. I got 11 and then 61. This is a decimal, rounds to 0.18. All right, now tangent. Notice now they're asking for tangent of k. So now I need to go to tangent of k. I go to k, I write in my opposite. Now my opposite's over here. My adjacent's right here, and this is still my hypotenuse. So tangent of k, SOHCAHTOA tells us to do opposite over adjacent. So the opposite from k is 11, the adjacent is 60. And this is about 0.18 as well, when I round to the nearest hundredth. All right, so I want us to use a special right triangle to write cosine of 30. So since I see 30, I'm probably going to be using the special right triangle that has to do with 30. So I'm going to do 30, 60, 90. Okay, so they don't tell me what the sides are, so I get to pick what the sides are going to be. I'm going to pick the side, the short side, to be S. Since the short side is S, to get from the short side to the long side, I double it, so I get 2S. To get from the short side to the long side, I just put a square root of 3 behind it. So now I'm going to do cosine of 30. Since this is the 30-degree angle right here, I'm going to do cosine from this point. So cosine of 30 tells me to do adjacent over hypotenuse. So I've got SOHCAHTOA up here. Cosine is the C, and that tells me to do A, which is the adjacent, H for the hypotenuse. So what I'm going to do is I do just that. Adjacent over hypotenuse is S square root of 3 over 2S. The S's cancel out, and I'm left with square root of 3 over 2. All right, use a special right triangle to tangent of 45 as a fraction. So again, special right triangle, this one has to be 45. If this is S, this is S. If these are S, this is S squared root of 2. This is from last section. When I do the tangent of 45, I'm going to do it from this one. I got SOHCAHTOA. Tangent is opposite over adjacent. So the tangent of 45 equals S over S, which equals 1. All right, what this is supposed to say over here is that make sure your calculator is in degrees, not radians. So when you put in your calculator, sine of 52, we should all have a graphing calculator by now. When I do sine of 52, I should get 0.78801075336. If yours is not in degrees, it needs to be in degrees. If you don't get this, then it's probably in radians, and we need to figure out tomorrow how to fix your calculator to be giving you in radians. You probably have to go to mode. If you have the graphing calculators, you go to mode, and you click over on the radian instead of the degree. So if you are not getting this, make sure you put something next to your buzzword to remind yourself to ask how to make sure I get this right answer. When I put sine of 52 into your calculator, you should get 0.79 because I'm rounding to the nearest hundredth. When I round to the nearest hundredth, you should get 0.79. So what the box is saying is similar, is about approximately. All right, cosine of 19 is 0.94551855756. So approximately 0.95. Cosine of 19. Tangent of 65 is about 2.144506921, so it's rounded to the nearest hundredth. This is about 2.14. Again, if you are not getting this, make sure you ask tomorrow how to put your calculator in the right. All right, the hypotenuse is always the longest side of a right triangle. We know this because it's always the C and it's always opposite the 90 degrees. So the denominator of a sine or cosine ratio is always the greater than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers less than 1. Since the tangent of an acute angle is the ratio of the lengths of the legs, it can have any value greater than 0. This is just kind of a side comment. When you do the sine or cosine, you're always doing the opposite over hypotenuse or adjacent over hypotenuse. Since what they're saying is hypotenuse are always the longest side, so your numbers are always going to give you a fraction less than 1, but greater than 0. So that'll just make sense kind of as we do more and more examples. All right, they want you to find the length rounded to the nearest hundredth. They want you to find the length of BC. Okay, so this is where we have to use the trigonometric ratios to find our lengths instead of using to find just angles and decimals and stuff like that. So what I want to do is write out my SOHCAHTOA. So based on where the degree is, I want to put in all of my information, my opposite, adjacent, and hypotenuse. Since I got 15 here, the opposite is at 10.2, so this is opposite. This is adjacent, and this is hypotenuse. So what I want to do is I need to look at which one they give me. They give me opposite. So I want to use my sine, cosine, or tangent that includes an opposite. So I've got sine has opposite in it, and I've got tangent has opposite in it. So I can cancel out the cosine. But now, which one's going to be helpful, the sine or the tangent? So I'm looking at here at B. I've got opposite. Now I need to ask, do I need hypotenuse or adjacent? Well, BC is my adjacent. So I've got opposite and adjacent. I don't want my hypotenuse. I want this side, so I use tangent. Since tangent is opposite and adjacent, I just put in tangent of 40 or 15 equals opposite is 10.2 over adjacent is BC. Now I just solve for it. To get BC out of the denominator, I need to multiply it into the numerator. What I do to one side, I need to do to the other. So I multiply it by BC over here. This cancels out. I'm left with BC times tangent of 15 equals 10.2. Now I want to get this BC to be alone. So I just divide out the tangent of 15. And divide out the tangent of 15. This cancels this out. And then in your calculator, you need to calculate 10.2 divided by tangent of 15. And then what you will get is BC is about 38.07. Do not reduce in your calculator. Do not figure out that tangent of 15 is about 0.267 and just round it to 0.27. Because when I do 10.2 divided by 0.27, I get 37.77777. That is not as accurate as this. So in your calculator, what you're going to do is hit 1, hit 0, hit decimal, hit 2, hit divided by, hit tangent, hit 15, and then hit enter. Do not reduce. Your calculator, if you've gotten the correct calculator, your calculator will be able to do this correctly when you just put it in. It will automatically do the right order for you. So you should thank your calculator. All right, 16, page 16. Do not round until that's basically what I just said. Do not round until your final answer. Use the values of the trigonometric ratios provided by your calculator. So just use your calculator's smartness abilities and allow you to be just as smart. All right, another example real quick. We've got to find DF. We're given an angle here. So I'm going to use D as my focus point. So put my opposite adjacent hypotenuse. Write my SOHCAHTOA so I remember the order. When I find DF, DF is right here, DF is my hypotenuse. Based on D, I have opposite information and I'm finding my hypotenuse. So the opposite hypotenuse is going to be right here at sine. So I need to find the sine of 51 is going to be equal to the opposite over hypotenuse. So we'll call it FD or DF. All right, now I need to solve. To get FD out of the denominator, I need to multiply it into the numerator. What I do to one side, I need to do to the other. So this becomes FD times sine of 51 equals 17. Now I want to get the FD alone, so I divide out sine of 51 on both sides. So FD is approximately 21.87. Again, in your calculator, you're going to hit 1, 7, divide, sine, 5, 1, enter. Do not figure out what the sine of 51 is, and then do 17 divided by rounded that number, because you're going to not get as accurate of a number. All right, last one. We have JL, and we have K is the angle that they give us. So I'm going to find from this point opposite, adjacent, and hypotenuse. So again, JL is over here. So based on K, I've got opposite, or I'm looking for my opposite, and I'm given the hypotenuse. So I'm going to be using OH again, the sine. So sine of 27 equals opposite over hypotenuse. I'm going to go ahead and change OP. Instead of opposite, I'm going to write JL, because that's the side that we're looking for. To get JL alone, I'm dividing by it, so I have 13.6 in the denominator. I need to put 13.6 in the numerator on both sides. Cancels that over here. So JL multiply is about 6.17. So again, in your calculator, you are going to put 1, 3, decimal, 6, multiply symbol, sign symbol, 2, 7, enter. Do not figure out this first and then round.